Good morning, my dear students. In this video lecture, I am going to discuss the oxidation of ketone and haloform reaction. Haloform reaction is also associated with your oxidation of methyl ketone. As we have already discussed the oxidation of aldehyde, that aldehyde is oxidized to carboxylic acid by using both mild as well as strong oxidizing agent. But ketone cannot be oxidized by your mild oxidizing agent such as Fehling solution, Tollens reagent or your Benedict solution. However, ketone can be oxidized by strong oxidizing agent at elevated temperature. For example, if we have a ketone of this type, RCH2, CO, CH2, R dash, where both alkyl group are different. Now, on prolonged oxidation, on heating with a strong oxidizing agent, then it will give mixture of carboxylic acid. Both have lesser number of carbon as in case of your ketone. The oxidation of ketone is due to the cleavage of your carbon-carbon bond. For example, if the cleavage is from this position, then the acid formed is your RCOOH plus your R dash CH2COH. Means this group is converted to carboxylic and this is also converted to carboxy. However, if the same ketone we have and if the cleavage takes place in this way, means if this bond will cleave, then the acid form is your R CH2COH plus your R dash CH2COOH. So the question is, which product is correct actually and which is your wrong, or you can say which one is major and which one will be minor. So for your information, in case of oxidation of ketone, the oxidative cleavage takes place according to Popov's rule. Now the question is, what is Popov's rule? Popov's rule कहता है कि जब भी आप कीटोन का ऑक्सीडेशन करोगे, then the ketonic group, that is this, then the ketonic group, this group will move over with your smaller alkyl. For example, if we write CH3CO, CH2, CH2 and CH3, when we oxidize it, then this carbonyl group, this will stay with your lower alkyl. Means the cleavage takes place from this position and then the acid form is your एसिटिक एसिड. देखिए ये दो कार्बन का एसिड हो गया, दैट इज योर एसिटिक एसिड, एंड दिस विल गिव यू 3 कार्बन एसिड, दैट इज योर प्रोपियोनिक एसिड. So this is your oxidation of ketone. Now next is, if you observe even your NCERT textbook, then we can observe the haloform reaction. So next is your oxidation of oxidation of methyl ketone. Now, not only methyl ketone, also aldehyde having this type of group. Whether there is aldehyde or ketone having this type of group, so this is your methyl ketone. For example, in aldehyde, if we use in place of G, there is hydrogen, then it is your acetaldehyde. It means in aldehyde, only the acetaldehyde will give this reaction. That is your haloform reaction. So what happens when acetaldehyde or any methyl ketone is oxidized with sodium hypohalite, then it will give haloform, and carboxylic acid is formed, The very important thing is the acid form has one carbon less. The acid form has one carbon less than the ketone. Now, haloform means it is your CHX3. If it is chloroform, it is CHCl3. If it is bromoform, it is CHBr3. And if it is iodoform, it is your CHI3. This reaction is also referred as your iodoform reaction or called your iodoform test. इस रिएक्शन को हम लोग देखते हैं कि ये रिएक्शन आखिर कैसे होगा. For example, if we have methyl ketone of this type RCOCH3, this is methyl group, so it is your methyl ketone. When it reacts with your NaOH, this NaOH is called your sodium hypohalite. It is your sodium hypohalite. Then it will give RCOCH3. This is your trihaloketone. You can say it is your trihaloketone. Now this trihaloketone on hydrolysis, if you hydrolyze it, then it will give. For example, if you hydrolyze with NaOH, then this will be your H, this will be your ONA. So the product is your CHX3 plus your RCOONA. This RCOONA on further acidification, it will give your carboxylic acid. For example, suppose if we consider acetone, and in place of your NaOH, if we use NaOI, this is called your sodium hypoiodide. तो खुद देखिए, यदि आप NaOI यहाँ यूज करते, then what will be the product? Then your product is, it is your CH3, it is CO, then we have CI3, that is called your triiodoacetone. Now this triiodoacetone on hydrolysis with your NaOH, this triiodoacetone on hydrolysis, this will give your CHI3. It will give a yellow precipitate of your iodoform plus your sodium acetate is formed. This sodium acetate on further acidification will give acetic acid. तो आप देखिए यहां जो एसिड बन रहा है इस कीटोन से एक कम कार्बन का, because in this acetone we have 3 carbon, while in this case we have only 2 carbon. So always we are getting acid 1 carbon less than your parent ketone, क्योंकि वो जो एक कार्बन था वो किसमें कन्वर्ट हो गया, in haloform, that is your, in this case it is your iodoform. So this iodoform reaction is basically used to distinguish between methyl ketone and other ketones. For example, let us suppose there is a question: how would you distinguish between pentane 2-one and your pentane 3-one? Pentane 2-one and your pentane 3-one. Now let us observe, this is your pentane 2-one. So this pentane 2-one is your methyl ketone. However, your pentane 3-one, 1, 2, 3, this is your pentane 3-one. This is not a methyl ketone. So this will give yellow precipitate of your CHI3, that is iodoform. It will not give. Similarly, if we have a question, how can you distinguish between your benzaldehyde and your acetophenone? मान लीजिए आपको ये क्वेश्चन दे दिया कि भाई ये बेंजल्डिहाइड है, ये एसीटोफिनोन है. सो दिस एसीटोफिनोन इट इज ए मिथाइल कीटोन. ये आपको मिथाइल कीटोन है. सो दिस एसीटोफिनोन विल गिव येलो precipitate of iodoform if you treat with NaOI. अब NaOI actually prepared by your reaction of sodium hydroxide and iodine. The NaOI, which is your sodium hypoiodide, required for the reaction is obtained by the reaction of NaOH and iodine. So what happens actually, this NaOH when reacts with iodine, it will give NaI plus NaOI plus water. This NaOI, it is used in your iodoform reaction. Similarly, if we consider NaOH plus halogen, maybe chlorine or bromine, then it will be your NaCl, or you may write NaX plus NaOX plus H2O. This NaOX, it is used for the haloform reaction. Now, this reaction is so important that even it will protect your double bond. For example, if we consider an example given in your NCERT textbook. For example, we have this type of compound CH3, we have double bond CH3, then we have CO, and then we have your CH3. Suppose if this is your ketone, it is your methyl ketone. This is your methyl ketone having a unsaturation, having a double bond. When we treat it with your NaOCl, that is sodium hypochlorite, then what will happen? This will form your chloroform. This will form your chloroform, and the acid form is your CH, then it is CS3, it is double bond, this is your CS3, and this will be your COONA. तो आप देखिए यहां जो एसिड सॉल्ट आपको बन रहा है, इसमें आपका डबल बॉन्ड रिटेन है. सो with protecting double bond, we can oxidize methyl ketone into the corresponding acid salt, or you can say simply in corresponding acid. Thank you.